And today I'm going to be explaining the Boyles Law that's used in chemistry to find out the relationship of the initial pressure and the initial volume from a gas to the final pressure and the final volume of the gas when a reaction happens. So for my example today, I have a Coke can and I have a drawing of the Coke can for the process of what happens before and what happens after I do an action. So first I want to look at the mathematical equation used. The mathematical equation is P1 V1 equals P2 V2. The reason why the numbers are right next to the letters, P being pressure, V being volume, and the 1 being the initial pressure and the initial volume on the left side of the equation, and then the 2 being next to the P and V on the right side of the equation, because that's when the reaction is done and that's when the finalized numbers of the pressure, the volume, and whatever units will be final. And with the Coke can, when it's closed, the gas particles, because there's nothing coming out of the Coke can, it's all closed, there's no holes in it. The pressure is very high, it's up, and the volume is down because there's really no space for the gas particles to just move anywhere. They're stuck right inside this Coke can. However, if I were to shake it up a bit, even when it's closed, nothing's happening, nothing's coming out, there's no reaction. In the inside, there's probably a little bit of activity with the gas bubbles going around. Now, once I were to open the Coke can, nothing much really happens. However, in the drawing that I have right here, the gas particles start to move out more because there's more space in there. So the gas particles take up less volume, and pressure now is the volume is higher now because there's more space for the gas particles to move around. Once the pressure was lowered, because now gas particles aren't in a tight space as how they were before when the can of Coke was closed. So initially, what that means between the relationship between the pressure and volume of gas is that it's an inverse. If pressure is high, volume is low. If pressure is low, volume goes high. So it's vice versa. After the reaction happens, if pressure goes up, that means volume's just going to go down. Volume goes up after the reaction, then pressure is just going to go down, just as in this experiment.